Hey guys, I'm Jade. Today is my LeetCode review vlog on the 380th problem. Insert, delete, get random big O of 1 problem. We have to implement the randomized set class, and we have several methods to be implemented. The first is we have to initialize the randomized set object. Then we have to implement insert method to insert an item value into the set if not present. Returns true if the item was not present, false otherwise. And then implement the remove method to remove an item value from the set if present. Finally, we have to implement the GetRandom method to return a random element from the current set of elements. And it's guaranteed that at least one element exists. When this method is called, each element must have the same probability of being returned. We have to implement the functions of the class such that each function works in average big O of 1 time complexity. And then let's get started with our intuition and main idea first. So our main idea is if we want to achieve big O of 1 time complexity average for all required methods, we need to use a combination of data structures that complement each other's strengths and weaknesses. So the intuition is use a combination of data structures. The first data structure we will use is a hash map, as hash map would only use big O of 1's time complexity to do insertion and deletion operation for only big O of 1. And the second data structure we want to leverage is array list, as array list can access and to support GetRandom for only big O of 1 and support random method for big O of 1. And here comes our new problem is how can we delete the specified value from array list with only big O of 1, as in generally if we want to remove a specified value in array list, it would take big O of n's time complexity. As if one specified value is removed, we have to remove all the elements behind the specified removed elements. And our solution is we can swipe the removed element with the lost element. And that's the key point. Then let's get started with our code and detailed explanation step by step. First, we can create several variables to help to solve the problem. First, we could create an array list with the generics of integer. Then we can create an hash map with the generics of a pair, integer, and integer hash map. And the value, every key in the hash map stands for the value of the stands for the value of the inputted element, and the value of the entry stands for the index of the inputted element in the nums array list. And we have to create the final variable. We could call it a random class. It comes from java.util.random instance. We have to create a new random instance so we can generate a random number or random index, and inside the randomized state constructor method we can initialize the nums and the hash map variables. So nums equals to new array list, and hash map equals new hash map. Then we have to implement the insert method. The first step is we have to check if our randomized set already have the same value. We can use the function contains key from the hash map. Hash map dot contains key of value. If the condition is true, we have to return false as the problem asks for. False means we already have the same value. If the condition is true, if the condition is true, which means we can insert value as we have already the same value before. And the second part is if it is a new unique value, we have to put it into the hash map and array list separately. So we have to put the value into the hash map, and the value of the entry should be nums.size, as nums.size stands for the new index of the new inserted element in the array list. Then we have to add it to the array list. Finally, we have to return true, which means we insert the specified value successfully. And that's all the code snippet for the insert method. Then comes to the remove method, which is very similar to the insert method. The first step is we also have to check if we have the same value element to be removed. So we can use hash map dot contains key of value to check. If hash map doesn't contain the key of value, which means we can remove it as we don't have the same value to be removed. So we have to return false, which means remove failed. Otherwise, which means we have the same value to be removed. So the first part is we have to get the index of the value to be removed in array list. And the code is index equals hash map get the get a key of value. And the second step is we have to get the last element in num's array list. And the code is last element equals nums dot get and the key should be nums dot size minus 1, which means the index of the last element. And the third step is we have to update the index of the last element in the hash map. And the code is this is the next step. Our third step is we have to move the last element to the index of the element to be removed. Then we can update the index of the last element in the map. So the third step is move the last element to the index of the element to be removed. And the code should be nums.state. The index should be index, and the value should be last element. Here comes to the fourth step. We have to update the index of the last element in the hash map. So it should be hash map put last element and the index, the new index. And the fifth part is remove the last element, as we already move the last element to the specified position. So is nums.remove the index of nums.size minus 1. And the sixth part is we have to remove the corresponding entry from the key map, which is from the hash map dot remove value. And the final step is we return true, which means we remove the specified value successfully. And here comes to the final method, which is GetRandom. We have to get a random value from our randomized set equally. And we can leverage the random class in our Java util. In the Java util package, we can use a return keyword and nums.get with the random instance dot next integer method. And the range is the max range. The upper limit of the range is nums.size. And that's all the code for this problem. And let's check for the correctness. Yes, it is got accepted. Then let's analyze time complexity and space complexity. So the time complexity is big O of 1 average, as the problem mentioned before, because we leverage the preferences and good parts of hash map and array list. So for each method like insert, remove, or GetRandom, the time complexity is big O of 1 average. And for the space complexity, it is big O of n, and n stands for the length of the inputted value. Because we create several variables to assist the solution. And for the nums and hash map variable, their length, it is corresponding to the size of the inputted values. So the space complexity, it is big O of n. And thank you guys for your watching. This is the end of my LeetCode review vlog for this problem. You can also check for the detailed notes on my GitHub repository here. I will put the link in my YouTube description below. And thank you guys for watching. See you next time.